Let's talk about the most extreme home ever built. I'm talking about the International Space Station. It's not just the most expensive thing humanity has ever constructed, it's also sitting in the most hostile environment imaginable. So let's dive in and see how we pulled it off. And I'm not kidding when I say hostile. Space is, well, it's trying to kill you. Every single second. Humans were just not built to be there. So this whole explainer is really the story of how some brilliant engineering lets us fight back and survive where we have no business being. The core problem is pretty simple, right? We need Earth to live. Our bodies are perfectly tuned for this planet. So to go into space for any length of time, we have to build a tiny, perfect, self-contained piece of Earth and haul it up there with us. I mean, that really is the question, isn't it? How do you survive with absolutely zero safety net? There's no air, no water, no protection from, well, anything. Up there, if one system fails, that's it. Everything we get for free down here, air, water, even safety, has to be engineered from scratch. And to put that into perspective, just look at the cost. Here on Earth, our life support system is, free. The planet just does its thing. But up there, to recreate those same basic functions inside a metal box costs a jaw-dropping $150 billion. That's what it costs to build our future out among the stars. So where do you even start with a project like this? It's not like you can build it on the ground and then just launch it. No, this thing had to be put together piece by tiny piece, all while screaming through the void at almost 18,000 miles an hour. And we're talking about a lot of hardware here. 460 tons worth. That's like trying to assemble 300 cars in orbit. The only way to do it was to fly each component up one mission at a time and snap it all together in space. It was basically the most expensive, high-stakes Lego project in human history. And what's amazing is that it all started with two former rivals. Back in 1998, Russia launched the very first module. A little while later, the US launched theirs and literally chased it down in orbit. It was this huge moment, really, turning the old space race into a new era of space collaboration. But pretty quickly, the engineers hit a snag. A pretty big one. See, the Russian modules were designed with round docking ports, and the American modules, yup, they had square ones. It was the ultimate square peg in a round hole problem, and the entire future of this massive international project hinged on solving it. So what did they do? They came up with this brilliant piece of hardware, the pressurized mating adapter. You can think of it as the universe's most sophisticated dongle. It's basically a converter block that let the square American side connect perfectly to the round Russian side, creating a perfect airtight seal. And with that connection, the International Space Station was officially born. Okay, great, the station is physically built. But now for the hard part, how do you actually live inside of it? To survive, the ISS has to perfectly provide the three absolute essentials for life. And let's start with the most obvious one, the air you breathe. Believe it or not, the station makes its own oxygen from water. It's a process called electrolysis. You just zap H2O with electricity and it splits into hydrogen and oxygen. Simple, right? Well, there's a catch. In zero gravity, bubbles don't rise, so the oxygen just hangs out in the water. The solution is genius. A centrifuge spins the whole mixture, forcing the heavier water to the outside and letting the precious oxygen gas get collected. All right, so you've got air. Now, how do you keep the station from getting shredded? The ISS is moving at 5 miles per second. At that speed, something as small as a fleck of paint hits with the force of a motorcycle. And get this, there are more than 500,000 pieces of junk like that being tracked in orbit right now. And trust me, this is not just a theoretical problem. One astronaut talked about looking out a window that had been perfectly clear just hours before, only to see a brand new 5/8 of an inch ding right in the middle of the glass from a tiny impact. It's a constant, terrifying reminder of the danger. So how do you stop these tiny bullets? Well, the answer is pretty counterintuitive. It's not one big, thick wall. It's actually a series of thin layers called a Whipple shield. The outer aluminum sheet completely vaporizes the incoming object. Then, a blanket made of Kevlar and super strong ceramic fibers spreads out all those tiny fragments. And the inner hull? It stays perfectly safe. It's like a bulletproof vest for a spaceship. The station is also dealing with absolutely wild temperature swings. We're talking plus 250 degrees Fahrenheit indirect sunlight and then plunging to minus 250 in the shade. The real problem is actually getting rid of all the heat from the electronics and the astronauts. You can't use water in the external cooling pipes because it would freeze solid. So the solution is, wait for it, highly toxic ammonia, which has a much, much lower freezing point. And last but not least, water. Every single drop is absolutely critical. The station recycles somewhere between 90 and 95% of all its water. We're talking moisture from your breath, your sweat, and yep, even urine. It's all collected and purified into water that is literally cleaner than most of the bottled water you buy on Earth. As one astronaut famously put it turns yesterday's coffee into today's coffee. So, okay, we've got air, water, and protection. You can survive. But now, how do you steer and power a home that's the size of a football field without needing constant and very expensive fuel shipments from Earth? Sure, you could use thrusters to nudge the station around, but that is wildly expensive. We're talking around $10,000 for every single pound of fuel you want to launch. So yeah, firing up the rockets every time you need to adjust your position is just not an option. They needed a fuel-free solution. And what they came up with is just elegant. They're called control moment gyroscopes. Deep inside the station, there are 4 massive 200-pound flywheels spinning at over 6,600 RPM. By simply tilting these spinning gyros, they transfer that spinning energy, that angular momentum, to the entire station, causing the whole 460-ton structure to pivot, all without using a single drop of fuel. It's pure physics, and it is absolutely brilliant. You know, all this mind-blowing technology isn't just about keeping a few people alive in low Earth orbit. The ISS is our laboratory. It's our classroom for learning how to actually live in space, which makes it the most important stepping stone for humanity's next giant leap, going to Mars. From that vantage point, 250 miles up, astronauts see our planet in a way we never can. They don't see borders or countries. They see this beautiful, fragile home, protected by what they call the thin blue line, that incredibly delicate layer of atmosphere. And it's a powerful reminder of why learning to live beyond it is so critical for our species' long-term survival. When you really think about it, the ISS is teaching us everything we need to know to survive a 2.5-year journey to Mars. It's where we prove that life support can actually run for years on end. It's where we study what zero gravity does to the human body. And it's where we learn how to truly live off-grid millions and millions of miles away from help. For more than 20 years, there's been a continuous human presence in orbit. The ISS is this incredible monument to human ingenuity, proving that we can build a home in the void when we work together. It's answered the question, can we survive in space? So the only real question left is, where do we go from here?